Want to give a brief intro here to the topic this morning and say we're on the verge of a historic change in the Northwest power system in a lot of ways. A lot of coal is coming out of the system, a lot of more renewables and demand side, energy efficiency, electric vehicles, potential for building electrification, major change in our system. And we have a new resource that we can develop in that system that can make all the other parts work better. And that resource is what we call flexible demand, or also known as demand response. Demand response is usually considered to be a fairly narrow thing dealing with reducing system peaks, peak load reduction, but we, as we'll hear, are thinking about that in a broader sense. That new resource involves a cooperative effort between utilities, customers, and in some case third-party providers. So it's no longer just the utility providing the energy and the customers using it. We have to have a cooperative effort. That's a big change from the past, but it's a very important, it will have a very important effect. Some of the things that that demand response or flexible demand can do is reduce system peak, but it can also help balance renewable energy, solar and wind. It can enhance the flexibility of the hydro system and provide a lot of other grid services. It's a really important possibility, and it's really quite big. The Northwest Power and Conservation Council has a demand response advisory committee. We were just meeting yesterday, and for the 2021 Northwest Regional Power Plan, their estimates are that we will have 2,600 megawatts of summer demand response and 2,600 megawatts of winter demand response and 3,600 megawatts of summer demand response. And some of us on the group think that those are underestimates. While it might not be possible to achieve all of that, historically, the council has been very careful in their estimates. And for example, we're getting at least 85% of their projections of energy efficiency. So we can, if we want to, we can get very, very high levels of demand response, flexible demand in the system. And that's what we'll talk about today. The largest single resource in the council's list of DR products is the humble residential water heater, the thing you never think about. It's in your basement or your garage. If you have an electric water heater, you're part of the future that we may see. As much as 1,000 megawatts of potential demand reduction over the next decade from water heaters, as well as other services they can provide. That's why we believe the work on the CTA 2045 appliance standard is so important for unlocking a major piece of the demand response, flexible demand future resource. And as we'll hear today, it's not just for water heaters, and it's not just for the Northwest. So I'd like to introduce our presenters very briefly, and then we'll get going. Conrad Eustis with Reascend LLC, formerly Portland General Electric. Geoff Wickes and Jeff Harris from the Northwest Energy Efficiency Alliance, NEA, and Tony Koch from the Bonneville Power Administration. We're going to get somewhat technical, so we will take requests for clarification after each presentation and hold the general question and answer till the end. You can ask questions in the chat box as the presentations go forward, and we'll come back to them at the end. And then after we handle all those questions from the chat box, we'll also ask for questions on the webinar and on the phone, so everybody will have a chance. If we can't answer all the questions before the end at 11 o'clock, we'll take those and post responses or send responses back to you. Any questions before we go ahead? You can unmute or put something in the chat box if you have a question. Okay. Now I'd like to turn it over to Conrad Eustis, and Conrad, it's all yours. And Kat, if you can.
Okay, good morning, everybody, and welcome. As Fred mentioned, I worked for PGE for 33 years, and in that capacity, I did demand response pilots since 1993. And so that informs a lot of my thinking here, and you'll see some of it as we go along. And Kat, I think I just say next slide and that happens?
Yes. Are you ready for
Okay, so next slide. Yep. Okay, so this is a little bit of humor, a little bit of seriousness. I like the bear because nature has solved actually the sustainable problem. And actually mankind had too. It's only when we invented the industrial age that we diverged from sustainability. But turns out we're going to need a lot of storage when we rely on wind and solar. But there's going to be cheaper resources than just storage, and less resources that take less material. And those are going to be flexible loads, and that's the subject of our call. So I'll go to the next slide now. So like I said, been playing with demand response since '93. And with all the pilots that I did, they were always coming up not cost effective. And the common thread that was even present in the mid-90s was that it's very expensive to send an electrician to a home to install things. And since then, the electrician costs have continued to climb. Hardware costs have sort of stayed flat in real terms, but altogether it's still too expensive. So in about 2005, there were working groups with advanced metering infrastructure. And in that time, I got triggered by the thought of putting a socket, probably given that USB was already out. And it would be a lot like USB. It would power a communication device that would plug in. And in that first context, it would just connect to the AMI system. But as it's evolved, that communication device can be anything, and we'll talk more about that later. But after the vision of 2005, there was a P&L pilot in 2006 and 7. And then we got to work on specification work with EPRI and the Smart Grid Interoperability Panel, created by the Energy Independence Act. And then EPRI started working on prototypes, and a very important part of what EPRI did was to define appropriate responses by device. And that isn't in the standard, but it is in the public domain, and EPRI did that for lots of devices. And then in 16 through 18, Tony, Geoff, and I, funded by BPA, led the demonstration pilot, and I'll talk a little about the results. And through NIA's prodding and a lot of help from others, Washington State was the right time with Jay Inslee's renewable initiative. And we got a law passed in Washington that said, starting in 2021, all electric water heaters will come with CTA on the device or with the device. And as it got implemented, electric tanks will follow a year later, but heat pump water heaters will be out of the gate in essentially 6 months from now. Next slide. What is CTA 2045? And it is, as I mentioned, it's a port, a communication port like USB. And one of the interesting things about USB is you plug in something into the USB socket, and somehow the computer learns whether that's a flash drive, a mouse, a keyboard, or any number of other things you can plug in. And that handshaking that takes place initially is embedded in what CTA offers in the standard. And that's a really important thing, because now both the communication device can learn what type of appliance is plugged in, and the appliance can learn what type of communication device. And more than that, they can determine what language to speak, and we'll talk more about that. But the beauty of this is there's no electrician required. And as the picture shows, there's just a place on the appliance where the customer, if they unscrew the access panel, and not all devices even have an access panel, can plug in a communication device. And in the near term, we envision the communication device would be supplied by the utility or the aggregator. But in the long run, if we really expand on the Internet of Things and you have in-home energy management, it could be that the in-home energy management will come with a kit of communication devices, and you go around to all your appliances and to plug in that, and they'll all come back to the energy manager. Another really key aspect of the standard is that it supports any type of communication method to get outside of the home. Of course, with Wi-Fi, you can get to the internet, but you could plug in a 4G LTE device. You can plug in a communication device that works with the utility AMI. You can plug in home plugs that travels over wires. Say you're controlling something in the garage or the barn. It could be Zigbee, although Zigbee doesn't reach really far. And more importantly, it could be any future communication protocol. 5G is starting to enter the demand response space. But anything that emerges in the future. And all you have to do is unplug one communication device and plug in another. And then the other aspect, besides the physical media that the communication signals travel on, is that it accepts any language. And so this is a really important aspect I'll talk more about, but OpenADR is often seen as a competitor to CTA 2045 or an alternative, but that's not the case. OpenADR is strictly a control language, as is Smart Energy Protocol or IEEE 2030.5, which is its standard name, and BACnet, and there's many more. It also means that the aggregator could be, say, speaking OpenADR, and the appliance can speak a different language. And then the communication device that gets plugged in can translate. And it's very easy, actually, to translate demand response commands as long as somebody writes them down and they all follow the same rules. And another important thing that I'll get to is the consumer experience in the next slide. Next slide, yeah. So once a socket like USB, all of us have figured out how to plug USB devices in. And through the magic of firmware and drivers, you know, they just know what each other are. Something pops up on your computer and you just start using it. You don't have to do anything. And in much the same way, you can plug in a communication device appliance, and depending on the communication media, the customer won't have to do anything. For instance, if the utility sends like a 5G communication device or a 4G, the customer won't have to do anything. However, when the customer chooses, or if the utility chooses you to do customer Wi-Fi, then what will have to happen is somehow the communication device needs to know the home password. And there's a lot of processes that are possible, but that enables one more step. And I mentioned I show the FM device that was used in our pilot. And this was a hybrid device where it can hear FM radio signals. And that's good because they don't depend on whether the customer's Wi-Fi system is working or not. And then there's the Wi-Fi, which for the pilot, we needed the data. So we returned the data over the customer's Wi-Fi. And another beautiful thing about FM is that it really exists pretty much in all of the US today. And so even though we had 8 utilities, all in different parts of Oregon and Washington, in rural, we could use FM. We enrolled different FM stations, but we all use that same technology. On the right picture, you see that there's actually 2 different form factors. The one you can get the scale of on the top is an AC form factor. The advantage of AC is that it can receive power line carrier signals like home plug through the appliance without any additional infrastructure. The lower one is a DC power device, meaning the socket on the appliance provides the DC power to power the device, and it's much smaller. I'm sure that it's about 1.6 inches tall, almost equally wide, but it's only like a 1/4 inch thick. So this can go into things like thermostats. Next slide. So I won't get into too many details of the pilot, but it's more important to understand the objective really is we were very interested in trying to quantify energy shifting. So that meant that we had to do different events multiple times per day. And because CTA, the fundamental command, which is a request to shed, is something the appliance can choose to do or not do. And that means if the tank's getting low on hot water, it'll probably ignore the command. And so that's what happens in every single home. And while that reduces the overall benefit a lot of the times, it does mean the customers rarely run out of hot water, which is really good if you're going to be controlling them every day or multiple times a day. We wanted to measure customer satisfaction. We wanted to quantify the KW and KWH benefits. And very importantly, we wanted to create a CTA market transformation plan. The Washington law sidestepped that and accelerated what that plan was, but we still might need elements of the plan that was developed. But based on the cost of that plan, we determined how cost effective that plan would be to implement relative to the benefits. And it was, as the results show, $230 million in net savings to Oregon and Washington. And that's when we were paying for all the market transformation costs. In Washington, that's going to be close to zero now. And we gained 301 megawatts of peak capacity savings. On the next slide, I'll talk about the energy savings. But we wanted to create also regional awareness, and this effort continues because we had a successful pilot. We're continuing to expand awareness. The only other results I want to focus on are the customer satisfaction. Over the 300 participants, 80% were very satisfied. Another, so only 20% were somewhat or not so satisfied. And it does turn out not every customer is suitable for a demand response pilot. If they use hot water a lot, they might not be, or if the tank's undersized, they may not be suitable. But generally speaking, it works really well. And even more important was their willingness to enroll in a future program. And 73% were very likely and 21% were somewhat likely. And I should point out the conservative results only assume 26% enrollment, and that only achieved over 15 years. And I'm very convinced that we can do better than that. Next slide. So everybody gets to win out of this, and Geoff's going to talk more about that a little bit, but utilities get benefits, customers get benefits, environment gets benefits. So I'll go to the next slide. So on the storage potential, because you can implement this twice a day without any impact on the life of the appliance, unlike battery storage, which every time you sort of cycle the battery, you take some life out of it. Batteries today might be good for 1,000 or 5,000 cycles, but we get to use it twice a day, at least twice a day, every day. And so that what we have, if you look at the 50 million water heaters in the US, electric water heaters, you get maybe 50 gigawatt hours of storage. And that's 10 times what's already installed, and there's been a lot of storage installed recently. And then on the marginal cost side, if you look at scale, there'll be about $10 for the electric resistance tanks to add electronics, but it's only like $1 in the heat pump water heaters. And then the communication module and modest scale is about $20 per communication module, but we're still talking lots of them. And that means your storage is less than $15 a kWh. And I'm not sure you can get that anyplace else. So it's a real plus. And as we get more renewables, that storage value is going to be even higher. So the next slide. So I want to go back to OpenADR a little bit, because it's really important to understand communication standards. And actually, it's a very complex subject. So I'm only going to simplify it and say communication standards, when we communicate, we actually use multiple protocols. And to use the example on the right with people, it turns out there's two really important parts. There's actually more, but two really important parts about communicating with people. One is you have to have the physical apparatus, right? We have ears and we have voice, and that allows us. And through genetic wonders, everybody on the planet has the same, ears and voice. And so we can always hear somebody, and they can always hear us. But if they speak a different language, then we can't necessarily understand them. Google Translate, that makes it easy. Point is, computers can make it really easy to translate, as I mentioned earlier, one type of language to another language. But communicating clearly, we have to have a standard language and a standard physical apparatus. And we're gifted in the human community that we all have the same apparatus. When you get into OpenADR and CTA, OpenADR is strictly a language. It's like Spanish or English. And there's others like Smart Energy Protocol. Actually, CTA 2045 has an application layer that's very separate than the physical layer, but it's an important option. And OpenADR is important. It was created for the commercial environment, and it works very securely over the internet, especially in businesses where no business wants hackers coming into their complex and operating equipment. So OpenADR is wonderful when you have to get through a company's firewall. And that's its real strength. And California developed it and uses it in the commercial sector, and it's very powerful for that application. But it doesn't, the electronics and appliances don't have the support to do all that security, and they're not necessarily connected to the internet. And so it really wasn't designed with mass market appliances. So what manufacturers do when they, quote, offer OpenADR is they support OpenADR in the cloud. So you enroll in a vendor's program, but you're connecting to their cloud. Then how do they reach the clients? They go through the customer's internet connection. They use the customer's Wi-Fi network, and then they have Wi-Fi on the appliance. But in that last leg to the appliance, those are all proprietary commands. There's no way the customer can access those locally in the home. They always have to go through the cloud if they're going to do something. And whereas CTA 24 is the physical interface. I've shown you the sockets and plugs. That's like the interface. And you take it one more step further, it's really just like the nerve endings, because you can change the communication apparatus. You can go from Wi-Fi to 5G, and you can actually change the physical media. So it's even more flexible. And another important point is CTA can support OpenADR, right? So you can use OpenADR as a utility to talk to an aggregator or to implement your commands. And ultimately, you can use CTA devices. You don't even have to worry about that. But the opposite is not true. If a manufacturer only supports OpenADR, then there's no hope for anything else other than the connection in the cloud. Next slide. So my list of disadvantages, I don't know, I think I'm probably overrunning my time. So I'll just really quickly say, in order to set that link up to the manufacturer, you're going to have a legal contract in many cases with that vendor, and you have the IT implementation with that vendor. None of that exists if you just send a device to the customer. Another huge impact is that most manufacturers that support smart appliances only put that capability on premium products. So the available products that you can reach via OpenADR is extremely limited. And worse, most people that buy premium products are not really interested in the economic savings you're going to offer them with demand response programs. So it's just the opposite. You want the low-end products that get into apartments, that get into the low-income homes, where they are going to be interested in whatever incentive. And then there's the Wi-Fi headache, and we learned that in spades with this project. The California utilities don't worry about that because they go through aggregators. But as utilities, if you're trying to reach out directly, Wi-Fi creates headaches for maintaining the connection. So customers' routers will fail, or they'll get a new internet service provider, or somebody will unplug the Wi-Fi, and the list of human things goes on. And that means you lose all your capability when that happens. And in our pilot with the FM, we didn't have that problem. Then there's the experience. It's not a universal plug-and-play experience with the customer. They have to enroll each appliance separately, and that enrollment experience can be different. And another problem is that it's a joint proposition with that vendor. So some will totally limit how you reach those customers. Some will not let you reach the customers at all. They'll claim they're their customers, even though it's a joint customer. They will claim you got to go through me. And so that's a recipe for disintermediation in the future. And that's only going to grow as Apple and Amazon and Google all get into this connected devices space. You won't be able to reach the customer, and they will. So just think about the long-term repercussions of that. You get stranded assets. Even in our project, the GeoSpring water heater product line ended. The IP was sold to a Chinese company, and if we had counted on the GeoSpring vendor, we wouldn't have been able to continue our pilot. Because it was a socket, there was no impact whatsoever. So a product is born with capability. If it has CTA, that product will exist till the end of its life with no limitations by the vendor. It limits innovation by entrepreneurs, meaning when you have an open socket, it doesn't require the utility to innovate or the manufacturer to innovate. Anybody can try to come up with a cool new way to, engage appliances. And that knowledge base can be made into a commercial enterprise or sold to a third party. But that's what innovation does when you open it to much greater people. And then OpenADR, as I mentioned, doesn't support. So if you're fed up with the interruptions of Wi-Fi and you want to go to 5G, that's not going to happen with an OpenADR approach. So next slide. This one was mainly just to say it should be really easy to mandate CTA on all appliances, but it's not. And part of it has to do with, the partisan politics that we have in the country today. And part of it has to do with policymakers are very cautious about picking a standard, mainly because they're so technical and they don't understand that not all standards are created equal. And so CTA 2045 is a standard that enables other standards, and that's a really hard message to get across. So what we have now is the opportunity, because of the Washington state law, to lead by example and show the rest of the country how fast we can go, because we have the capability starting next year. Next slide. And so just a more on this, another paradigm shift that's happening is that if you think about it, for 120 years, the only customer role was to consume electricity and, of course, pay the bill. And in the next era, though, as we get renewables and we get sustainable energy, to get a lower cost solution, customers have an important role. And that role is to accelerate the arrival by using more renewable energy at times when it's actually there. Sort of like clothes drying on the clothesline, you do that and it saves energy. In the demand response space, it means using more energy. The customers aren't going to babysit their appliances. And we need a simple way to make that happen. And that simple process is created by CTA 2045. But we're just at day one of this new opportunity. And this is going to take an education process over the next couple decades. So we need to start now. And the footnote is really important here, which is, at least in the Northwest, most customers want to help with renewable integration. Of the participants, when we asked them why they would volunteer in a future program, 62% they wanted to participate because that would allow them to use more renewable energy. And so that's a really, we're helping them help themselves. Okay, next, I think maybe last slide. No, that's it.
All right, thanks, Conrad. First, I just want to express some appreciation for Conrad's vision and patience and determination. It's been absolutely pivotal in setting us up for where we're going. I wonder if anybody has any clarification questions, not general Q&A at this point. You can go ahead and type in the chat box, and I think we can get everybody, if you want to unmute, you could also do it on voice. And we've seen some good discussion in the chat already. Keep that going. I will keep an eye on that, and any questions that come up for our presenters, we can come back to in the Q&A later on. All right, let's move on here. Next presenter, I'm not sure which of the Jeffs is going to present, Geoff Harris or Geoff Wickes. So whichever one of you is going to do this presentation, please go forward. And Geoff Harris, Kat, do we have to unmute Geoff here?
Yeah.
Fred, this is Geoff Wickes with NIA. Geoff Harris is going to run this for now. I'm going to be available as a resource.
Okay, thanks. Okay, Geoff, yeah, there we go.
Kat, I'm on my cell phone. Can you hear me on the cell phone?
There's some background noise.
Yeah, so hang in there, everybody. We'll figure this out.
So Fred, if you want, I could possibly get started while Geoff works that through. I don't want to hold up.
Yeah, well, you guys can handle it however you wish.
Okay. So while Geoff Harris is getting this figured out, and Geoff, interrupt anytime you're back online. So NIA, as you know, is a market transformation organization, and we are looking at what the future state looks like. And we are looking at all water heaters, 40 gallons, electric water heaters shipped to the Northwest, come with an open source communication interface of CTA 2045. We view this as a viable option for the integration of renewables, and we think this is a really important key element to the integration of renewables and balancing the grid. Energy Star is moving, and DOE is starting to recognize CTA 2045 as the protocol of choice. And utilities can integrate and can utilize this valuable resource, as was mentioned both by Fred and Conrad, of a significant amount of load shifting, and or once we get into time of use rates here in the Northwest, this would be the resource we can use. Aggregators across the country are successfully leveraging this. There's a study, a meta study that we're doing now. We've got well over 20 studies across the US and Canada, totaling more than, I think, 1,500 water heaters that have been controlled with CTA 2045 with great success. So, Geoff, are you back online? Next slide. Geoff, are you there?
Yeah, Kat, we may have to unmute Geoff.
I'm asking to unmute, but
Geoff, you may, oh, there we go, okay.
Kat, this is, I'm actually on my cell phone too. Can you look for number 503-816-5665?
okay.
There we go.
Can you hear me now?
Yeah, that's a lot better.
Okay.
Go ahead, Geoff.
Okay, thanks. Is the audio okay now?
Yeah, it's just fine.
Great, thanks. Okay, sorry for the technical difficulties there. So this is a chart from the report that came out of the Bonneville PGE and NIA water heater study. And again, Conrad deserves huge credit for envisioning that and then making it happen. This graph has a lot of information on it. I'll try to be quick about it. It has two different things that it's representing here. One is, this is a picture of a transformed market for grid-enabled water heaters, which is what we call them in the Washington state legislation. And on the left axis, you have the number of grid-enabled water heaters in thousands being adopted each year over time. And on the right-hand side, you have an estimate of the number of megawatts that are under control. And the legend shows you a dashed line. That's the upper dashed line. It says installed numbers of smart water heaters. So thanks to Washington State, we're actually going to be ahead of schedule on that chart, showing that each year we pick up another couple 100,000 water heaters potentially that are installed with CTA 2045 capability. And that would be true if we get everybody to require this in electric water heating devices. The dashed line is another number of smart water heaters, but that's the number of smart water heaters for which their owners have enrolled in a utility program. And as Conrad mentioned earlier, the number of enrollees here is a pretty conservative assumption. It's around 23%. And if we achieve that 23% enrollment, then you would get something like excuse me, the green curve that's a smooth line. And you can see that by 2030, if we did that, we would achieve 100 megawatts under control out of the installed devices that we have. Now, that's not something to sneeze at. That's significant. But as Conrad mentioned, we think we could do a lot better. And one place to do a lot better is simply to increase the customer participation rate. So the red curve, the red smooth line, is an example of what we could do if we could get 75% participation levels out of the same number of heat pump water heaters installed. And if we were able to get 75% participation, then instead of 100 megawatts under load control, we would be able to have 250 megawatts. And by the end, the chart doesn't go that high, but we could have well over 500 megawatts under control by 2039. And this is all built out of a natural replacement cycle where people have water heaters fail, and they're replacing those water heaters over time with devices that are CTA 2045 enabled, and then they're enrolled in a program and are able to be accessed. So I just wanted to show this picture because I think in the original report, we were being quite conservative in terms of the amount of water heaters that participate in this program. And I think Portland General Electric's demand response testbed project, which is using an opt-out program response model, has shown that you can have very high participation levels with an opt-out model and still have fairly high customer satisfaction rates. And we believe that that's possible here because in the Bonneville PGE NEA demonstration project, as Conrad mentioned to you, there were very high levels of customer satisfaction with the CTA 2045 interface. Most people had no idea that they were being engaged twice a day. I mean, if we hadn't told them, they wouldn't know. Most people never knew that their water heaters were even being accessed and used for energy storage. So I think a higher participation rate is quite possible. Okay, next slide, please. I won't spend a lot of time on this. Conrad already did quite a bit of this work, but suffice it to say that based on the demonstration project, we believe that there are values to all of the different groups on this screen. Customers, they save money, probably not as much money as they could get in terms of social value back from being part of a solution for the grid that enables higher levels of variable output renewable resources. And so people who participate in this can legitimately say that they're helping to reduce greenhouse gases by encouraging and using more renewables. Utilities benefit because now they have a flexible load that they're connected to, but they didn't have to necessarily buy the device. The water heater is being purchased because people need water heating. And again, Conrad showed you the economics on that. From a utility perspective, this is a very low-cost way to have storage available. And the grid benefits. There is, I'll just say one thing about the bottom there, smart cities and states. There is a low income opportunity here because the demographics show that there tend to be, in our region, more electric water heating in the lower income demographics in our region. And so this provides maybe more benefit to that population. And also the economic advantage, if the utility values the flexible demand resource, that income stream might not mean much to a middle income household, but it might mean significant amounts on a monthly basis to a lower income population. So I think I'll move on to the next slide in the interest of time here. So you heard this from Conrad again. The need for intervention and support is really all about scale. If there's one thing I want you to take away from today's presentation, it's this. Any one water heater is tiny in terms of the amount of peak reduction or flexible load engagement. You know, it's somewhere between 200 and 350 watts. That's not a lot. But we have about 2.5 to 3 million electric water heaters in this region. So multiplying that number by 1 million results in a pretty big resource, as you saw in the previous chart, where we think we can get up to 250 megawatts of peak load resource to manipulate. So, and just to put some other numbers on it, to get to most utility dispatch operations or market transactions won't occur below a 25 megawatt level. It's just too small for the market systems and the dispatch operators to deal with. So that means that we've got to get 60,000 just to be able to play in the game of dispatch and market valuation. So that gives you some idea of the scale that we have to get to here. We also need to get high levels of customer participation. You know, in order to have an equivalent of a large gas-fired turbine for peaking purposes of around 250 megawatts, as you saw in the previous graph, we need to get over 75% participation if we're going to get there by 2030. And by 2030, the resource adequacy folks are telling us that we need maybe upwards of 3,000 megawatts of peak that we need to be able to move around if we're going to provide the resource adequacy for the regional system that we need. The OEMs, the manufacturers, they need scale because that's how they're going to lower that cost per unit to get to the, you know, $10 to a few dollars per water heater tank, and also to get down to the control device, the communication device, the module that connects the CTA 2045 interface to the real world. In order to get down to $20 a device, we've got to have large scale. And then lastly, we need lots of scale in order to accommodate just the diversity of usage in any given population. So while there are good statistics on the load shapes of these things, in any given day, at any given moment, there will be tanks that will be charging and won't be able to participate, and there will be other tanks that will be sitting idle if we don't access them. So scale, it's all about scale. Next slide, please. So the good news is that we have some real opportunities here in the Northwest, and the first one is that we've got about 200,000 electrically fueled resistance and heat pump water heater tanks each year. And so that's a transaction that's going to happen with or without us. And so that's awesome. Washington State saw the value of engaging with that by itself and passed a law that said that all electric fueled water heaters have to have this capability starting in 2021. That's a great start. So now it's no longer a question. Each year we're going to be adding Washington State's part of that 200,000 each year. Another opportunity is that heat pump water heaters, the nominal cost to do this is almost nothing because they have very sophisticated controls already built in order to manage the heat pump water heater itself. And they have multiple operating modes, so they give more flexibility in terms of what the water heater can do in terms of participation in grid commands, and they virtually all of them have connectivity already built in. So this actually provides a good rationale for heat pump water heaters as the preferred electric water heating solution. Customers are also, on the customer side of this, we've talked about this, but there are some good value propositions. I've been reading some of the chat box stuff. Jim Lazar mentioned some studies in Hawaii that said that, you know, people, first off, are interested in smart devices. And so there's a certain percent of the population that would just think it's cool to have a water heater that does this kind of thing for them. But more importantly, many people, if you said, if you could do something just that's almost invisible to you, let the utility control your water heater to absorb more renewable energy at the right times and decrease our requirements for fossil fuels, would you do that? Most people would say, sure, if it doesn't change anything for me, as long as I still have hot water, I am happy. So I think we have actually a good customer proposition here. And then we do have this opportunity in standards. Washington's already done it. We think Oregon, through the executive order that Governor Brown issued earlier this year, is working on similar standards through an executive order that she issued, and the Department of Energy is working on that. The legislature will have to approve that at some point in the future. So we've got a good start. California is also working on this from both a new construction perspective in Title 24 and a standards play in Title 20. We see at the national level, the Energy Star is considering connectivity as a future requirement, and CTA 2045 is a strong consideration for that. And then there are lots of national partners outside the Northwest who are really interested in low-cost energy storage. So we think there are extra regional partners that could support an increase in scale in terms of getting to scale. Next slide, please. But unfortunately, there's also a lot of barriers. There's a lack of transparency or even flow of value from the manufacturer or from the water heater and the demand management value that it derives back to the manufacturer. So there are added costs. Today, maybe not so much for heat pump water heaters, but for electric resistance water heaters, there is a cost to add the features to the water heater. More importantly, at this point in time, the communication modules are still expensive, relatively speaking. There's also the fundamental problem that we're talking about water heaters, and frankly, nobody cares about water heat. As long as we get water, hot water, we really don't care how we get it. Study after study has shown that people just don't pay attention to it. Once it's in place and it's functioning, we have better things to do with our lives, and so we don't pay attention to it. There are legitimate concerns about any grid connectivity that might reveal something to a third party. And so there are privacy and security concerns. I don't want to downplay that. And there have been performance concerns, but I think that we demonstrated in the Bonneville PGE NEA pilot that there were completely satisfactory outcomes from a water heater perspective. I mean, that's the beauty of the CTA 2045 command structure, and the devices are autonomous. If the tank is in heating mode and it still needs to keep going for another hour, it will simply ignore the request from the grid to do something, and will say, sorry, I can't do it right now, unless there is a grid emergency where the water heater has been pre-programmed. It's like, oh, the lights are going to go out if I don't go off. And so it does have that functionality built in. There's some other things here that I won't go into in the interest of time, but suffice it to say that water heating is a hard market. We've been working on heat pump water heaters in the Northwest market since 2008, and we can attest to how hard this thing is. Next slide, please. Okay, so where do we go from here? We feel that we have a good value proposition, and that we could bring on this storage at very low cost per kilowatt hour to help the region absorb more renewables, and to also help maintain grid reliability. But it's not going to be easy. So the way that we're thinking about it at NEA is that there are sort of three legs to the stool to get to where we want to be from where we are today. One leg of the stool is equipment, hardware. And the other side is the customer engagement and participation leg of the stool. And then a third leg of the stool is the utilities themselves, in terms of how they engage with the device, engage with the customer, and that has to do, or has a lot to do with utility operations and being able to capture the full value of this opportunity. So let's take a look at each of those in the next couple of slides. Next slide, please. So from an equipment standpoint, good news. We're doing well. We got the Washington standards, as I mentioned. Heat pump water heaters will start being required sooner, but the electric resistance water heaters, all water heaters in 2021 will start being CTA compatible. Oregon, as I mentioned, is also working on that. We're not sure exactly when that would take effect, maybe 2022. I've also talked about California. Conrad talked about Open ADR. Open ADR and CTA 2045 are working together and looking to figure out how they can be more closely developed together, which is an awesome thing. So that's all good news. And as I mentioned earlier, Energy Star is looking to embed CTA 2045 in their communications requirements for Energy Star appliances. That's awesome. But where we have a gap is in yellow down below. Today, or I should say, let's say in 2022, a water heater goes into Washington State and it is ready in that it has CTA 2045 capability, but let's call that dark capability, because without a module, a communications module, you can't even access that capability. So we need to figure out some way, if we could, so that every time we get an installation of one of these water heaters, it's also ready to talk. And so I just put in quotes here, COM-ready installations. How do we do that so that the utility can know that the minute that water heater is installed, that it's ready to light up? And we could do that either in the field, or it might be possible to know where water heaters are being shipped within the region from the factory, and we might even be able to get them installed at the factory. If we could do that, we could do it at much lower cost. Okay, next slide, please. On the customer side, we have some pretty big gaps. And the biggest one is that apart from PGE's testbed, DR testbed project, we don't really, as far as I know, have any examples of high participation customer recruitment programs for demand response. And the only one I've seen with the level of participation rates, as I said, is the PGE opt-out model. And I think that's what we're going to need going forward. And this might be a really good case for an opt-out model because, frankly, again, people don't pay attention to their water heating as long as they're getting the water heat that they need. They are happy. So we need to have some discussion, some dialogue with both utilities and regulators about how to make that happen. The other thing is, in order to make that happen, if you're going to have an opt-out model, you do need to have good consumer messaging that's targeted for their value systems. And the good news is we feel like we have a good value proposition for a whole range of customer values, including, greenhouse gas reduction, increased use of renewables. They're participating literally in getting more out of the renewable energy systems that are going in place. And for folks on the east side, this increases our energy independence because we don't have to then have imports of fossil fuels from other places around the world. Okay, so that's a leg of the stool that still needs some work. The next slide, please. On the utility side, there's some things in motion. The good news is that there's more and more utilities who are installing distributed energy resource management systems into their operations so that they can access and dispatch not just hundreds, but thousands, if not hundreds of thousands of devices. That requires some utility capital upgrades as well as some operational practice changes. But those things are happening, so we're beginning to see that happen. And we also have valuation systems now in the markets. We have the energy balance market. Folks are working on the day-ahead market. And that's going to provide some economic signals directly back to utilities that if they could take this energy storage device and exercise it, then they could actually see economic value returned in both those two markets in the near term. So that's good news. And then, as the resource adequacy forum is moving ahead, there's likely to be something that pops out of that that will also provide value in economic terms for contributions to resource adequacy for the region. Good, that's great. What we do need, though, is we need operations practices that can exercise this type of equipment to get the full value out of it. So Conrad did a beautiful job. In case you can't tell, we all have a high degree of respect for Conrad's commitment and patience, as Fred said, to making this demonstration effort work. And one of the things that was remarkable about it was that Conrad had the vision and foresight to see that we needed to show that you can exercise this resource multiple times a day. And if you could do that, then you can capture, like I said, the energy imbalance market benefits or day ahead market benefits, rather than just exercising it as a traditional DR on-off emergency basis 10 times a year resource. But to do that, Conrad would be the first one to say it wasn't a cakewalk to get his own dispatch folks and operations people to do that and to recognize the value of that. We still have a ways to go in terms of operational practices within utilities to capture that value, to recognize it and capture it. There's also an issue of planning processes in T&D and resource planning, that we need to be able to recognize that this resource is real and it has value, and if it's put in place, it could displace or essentially become or avoid the cost of a T&D upgrade or avoid the cost of a peaking resource, either a market purchase or a physical resource. Right now, this is not in the realm of the integrated resource planning or T&D planning tools that are out there today. So we need to upgrade those processes to recognize this value stream. And then lastly, we need regulatory models that will support an opt-out customer model. I realize this is controversial. It might be the most controversial of all the things that I've just talked about. But being able to have high levels of participation requires some way. I believe opt-out models are probably the way to get there, but they're certainly not the only way. But for something with a fairly small increment value, economic value to an individual consumer, $10 a month or less, how in the world, that won't get as much attention or participation as if you do an opt-out program and then say, we're doing this for the whole grid, everybody participates, but you can opt out if you want to, but if you stay in, you get $10 a month. That's a very different discussion with customers than would you please do this for $10 a month. Okay, next slide. I'm just about done. So where do we go from here? Given what I just described, I think we have this opportunity. Washington's already gone first, but let's keep going if we could. Let's get Oregon to have standards that require this capability in electric water heaters in Oregon, and Idaho and Montana are other opportunities for us in the Northwest region. I think there's a regional program opportunity that if we could figure out how to coordinate, it would make it easier for aggregators or for utilities to turn these, well, I'll call them dark assets, which is what's going to start showing up in Washington State, turn those into COM-ready, flexible load assets that the minute they're installed, the utility could be notified and could start exercising that water heater the minute it shows up. And then thirdly, we need to figure out a consumer-friendly opt-out engagement model that allows us high participation rates. And I realize that's controversial. The real goal is high participation rates. And so I would welcome different models other than an opt-out model if you could show me that we could get to 75% participation rate. Okay, with that, I'm going to close. One more slide. I just want to go back to that slide I showed you. what's at stake on participation rate? Yes, it's controversial, but if we could get to the participation rate, it's the difference between a 100 megawatt resource in 2030 or a 250 megawatt resource in 2030. That difference is significant, and I feel like it's worth having the conversation in the region about how do we make that happen. So with that, I'll end.
All right, thanks, Geoff, and Geoff Wickes, who had to go off to another meeting. I'd like to move on now to Tony Koch. I realize we're running a little behind our schedule here. So Tony, please take the time you need, and we'll save a few minutes at the end for more questions. I'll pick out a few questions out of the chat. We've been having a good interaction in the chat, so that's answering a lot of the questions. And I think what we'll do is any questions that still remain at the end of our time, we'll take those and compile a response from all the presenters and put that on our website. So Tony, if you'd like to take over, go, it's all yours.
Okay, hello, can you hear me?
Yeah, you're fine.
Okay, thank you. Luckily I have, I'm brief, I'm short, so it's good that lasts. So let's move to the next, the first slide. So even though we're talking to scale and water heaters are wonderfully moving into scale and just we're very pleased about that, everything starts with a seed. Everything starts with a nugget, and actually started with Conrad. I remember a good 6+ years ago in a similar presentation like this, where I first got hit with CTA 2045. What is that? And here we are, part of the core team moving this forward. So I want to just refresh the audience that the standard was intended to be multi-appliance, anything. You know, so we're not going to DR a toaster, but certainly we could move into other appliances. And so water heating is the premier DR load. But really what's interesting here, what I'm going to talk about is moving on over to HVAC. And before I do that, I just want to also acknowledge seeds and individuals, and in this case, corporations that have that come to the table initially and really start to break some ice. And that was A.O. Smith, who did that in the water heating space. They were there along in the early stages with EPRI, doing the heavy lifting of how does this thing work and so forth. And they were the premier manufacturer that led the way, and others joined. So next slide then. And so the analogy is Mitsubishi is that vendor in the HVAC heat pump space. They are to our knowledge, the only manufacturer right now that offers a 2045 port, again through an adapter. So it's a proprietary port in the unit itself, used for many different things, but they built an adapter that translates their proprietary algorithms to open 2045 in a DC form factor. So in the latter part of last year and this year, BPA, myself, with a couple other colleagues, have been doing a handful of testing in colleagues' homes. This is utility personnel or even BPA folks, and actually trying and successfully doing shed. Now, in the Mitsubishi has chosen to implement basically the thermostat command, which is a delta from the set point. So as a dispatcher, I choose 1, 2, 3, 4, 5, whatever degrees Fahrenheit delta offset, and I send that to them. I chose 3 degrees, so it changes the thermostat in the home, and the thermostat that's being controlled, change it, and it must be it needs to be a Mitsubishi thermostat. So there's still some limitations in this early going. But it's been very rewarding to see we've been able to actually do that physically in the field, out of the box, and we leverage communication modules that we use for the water heaters in the Mitsubishi. Now we gave them a firmware flash upgrade with the manufacturer eRadio, but they're the same piece of hardware. So that's the other part of the standard is multiple appliances. And if I'm a utility, I want to have one set of communication modules that I plug into my various loads, water heaters, heat pumps, electric vehicles, pool pumps, what have you. I want to have one set of communication modules to work in multiple appliances. So this is another demonstration of that. And then just at the bottom, I want to show that we are actively engaged with PNL and PG to actually recruit, off the street type customers in small quantities, again, maybe 10 to 20 customers, and run a little bit more of a formal test bed. They'll be this fall through this next coming winter. So this is the early work that was done also in water heaters a good 6-7 years ago. That's now we're moving on to the next appliance, if you will. And then the next couple slides, I want to get into a little more detail about the Mitsubishi systems. So first, ductless. So most of you know what a ductless heat pump is. So on the far right, I just put a single outdoor unit, single head, very common, just one node inside. And so you see the blue circles is the controller, which is basically the thermostat, like a TV remote that just sits somewhere in the room. And the adapter is the circle in red. So that's the physical piece of hardware that needs to be attached to the head inside. And then we plug in the communication module into that adapter. And then on the left, lower left, I'm just showing, and we actually did a home, we've instrumented a home where we have a fairly good size outdoor unit and then multiple heads inside. And in this specific case, we have 5 heads inside a home. So it's really conditioning the whole space inside. So, but you have to, and so I'm showing there in this application, you have to go and touch each one of those indoor devices. So on one hand, in this application, we have, so I'm giving you some early findings on the lower right. There's been no issues in terms of getting access to the port. So these devices have it's called the CN105 port. It's a multi-function port for Mitsubishi. You can connect to the cloud for customer applications. You can do a wireless thermostat. You can do, things like that. It's kind of an auxiliary port for many different things. And then we use that port for the 2045 adapter. So because these ductless heads are controlled with a handheld unit, there's been no issue in getting access to the port. So the port is available, we can plug in. It's kind of hard to get to, but it works. There's no issues there. But it's not very cost effective because you got to deploy these systems to every head. So it's not as, it's just you're spending more money in the hardware. Next slide, please. So now I'm in the central ducted system, which was also an interesting finding that Mitsubishi and Daikin and Fujitsu and the main players have a replacement ready to go for the central, ducted central air US HVAC system. Very interesting, and what an interesting opportunity to bring a high performance heat pump into that space. So it's, if you will, if you don't mind the terminology, this is a ductless system in a ducted house. That's kind of the application. So here we do have a traditional thermostat, and so the same things apply, but now you'll see on the lower right again, different set of issues. Because residents are using that auxiliary port almost every time we run into this opportunity, it's being used for a wireless thermostat. So, and there's only one port. So we get blocked out. We can't use it. We can't plug in because there's no physical port to connect to. So what we've done in a couple cases, we've worked with a customer and we moved on over to a wired thermostat. So the central blower has a different physical port to bring in a wired thermostat. And so that opens up this auxiliary port, the CN105 port, and we've been able to plug in. But that is a major issue. Contrary though to the ductless, is this is a single point of measurement, single point of control. You get the whole house load. Very attractive. So I mean, very cost effective from that perspective. And I'll go to the next one. And so what's happening into the future? We've made contact with production and at the company, at the facility and manufacturing Mitsubishi, and we're in dialogue with them and communicating these issues with them, and they're hearing us. And there has been some small progress for them to bring more features into the command set. We've asked them, hey, can you give us indoor temp and communicate back to the module? Can you tell us if the compressor is running or not? I mean, we'd love to get wattage of the whole system, which is the kind of data that we can get out of 2045 commands. But so we are engaged with this manufacturer to improve the data stream and the capabilities that that offers. And so what's important there is it's very similar to the water heater work that was done in the past few years. If you work with a specific vendor who is willing to invest and continue to mature the product, others will follow. So I'm very excited about this model. And, so we're getting out there and doing stuff with Mitsubishi and, running these small little application things and sharing that work so that other manufacturers can get wind of this and maybe join. And then my last slide is just a summary. Again, we've talked on OpenADR and CTA 2045. I used this slide earlier in a California presentation, so I just want to share it again for you folks. And again, the message is they play well together, but it's not an alternative. OpenADR can be deployed through CTA 2045, but not vice versa. And at the bottom, I just want to clarify what I'm speaking to there. So AHRI did put together and finalized a standard for demand response control, but we're very disappointed in that standard allows either OpenADR or 2045. So what kind of message is that to a manufacturer? It's like you say, hey, if you're a movie entertainment manufacturer, you can build data or VHS. Go for it. Well, that's not going to work. We need one. You standardize on one. So it's kind of a cop-out, is my point. And then Energy Star in their draft proceedings followed suit to AHRI. So I kind of point out the same thing. You need one or the other. I mean, you can't say both are okay. It'll confuse manufacturers. We won't have stability. So anyway, that is sort of still maturing, but I just wanted to, in terms of this OpenADR 2045 discussion, we need to mature the discussion, understand the application of both. Both are wonderful standards, but just understand how they play and what's the applicability and the correct application. And Fred, that's it. Thank you.
All right. Thanks very much, Tony. And I just want to give full credit here to the Bonneville Power Administration and Tony and the others at Bonneville, Lee Hall, Frank Brown, and others who have been absolutely solid in supporting the effort to build up CTA 2045, the water heater pilot, the previous work with this PNNL Smart Grid Demonstration Program over the last decade. Without their commitment and effort, we would not be where we are now. So I just wanted to say thanks to Bonneville for that. We do have some time here for the remaining part of our webinar before the hour for some questions. So what I'm going to do is go through the chat box questions, and I'm going to partially arbitrarily pick out a few that have, I think, that have some broad interest and get some response from our panelists, and then we'll see how far we can go with that. And as I said, we'll respond to all questions in a follow-up document that we'll post to our website. So first, going way back, Mark Frankel asked a question: in the context of goals to transition to heat pump water heaters, how relevant will electric resistance deployment be? And I think that's a good question for Geoff Harris. Geoff, if you can unmute there.
I'm sorry. Can you hear me now?
Yeah, you're fine.
Yeah. Okay. Could you repeat the question for me, please?
Basically, the question is about the relationship between market saturation for electric resistance versus market development for heat pump water heaters.
Yeah. So at the moment in the Northwest, our market saturation or market share of heat pump water heaters is less than 10%. I could be off by a few percentage points either direction, but we're still not anywhere near the majority yet. We think that we at NEA believe that that number could be much higher, and we actually see in the studies that we did with the Bonneville PGE pilot project that the difference in dispatchable kW was a little bit lower for heat pump water heaters, but surprisingly, there was still a significant opportunity there for dispatch from a flexible load standpoint for heat pump water heaters. And they have this native capability now built into heat pump water heaters at almost no incremental cost. So I guess from my perspective, it would be a terrific step for the region if we could figure out a way to just sort of skip past the electric resistance CT 2045 enabled water heater and go right to the heat pump water heater. In terms of economic value, the heat pump water heater provides a 50% reduction in overall energy consumption for water heating for the end customer. So there's an immediate benefit to the end customer that continues through the life of the device, and a substantial carbon benefit from the energy efficiency in the heat pump water heater. If we could, as a region, figure out a way to, rapidly accelerate our adoption of heat pump water heaters as the electric water heating choice, we would see additional benefits in the region in both carbon reduction and peak load reduction, and customer bill savings. So, I guess I'm on my sales pitch here, but NEA would love to coordinate with, and we are already coordinating with utility programs and others, but we would love to talk to anybody who has an interest in accelerating that adoption rate.
All right, thanks. And that you touched on a point I was going to ask about, which is the relationship between the energy efficiency side and the demand response side. We're at Northwest Energy Coalition completely supportive of finding the synergies there everywhere from, the kind of combo effects to, to decrease truck rolls to, you name it, program administration benefits and grid benefits overall. Getting a combination of all the demand side resources together is really what we're after. So thanks for that. Nancy Hirsch asked the question. Yeah, sorry, go ahead.
I just want to, in the transition, Geoff points out that, we still have a ways to go to build up heat pump adoption, and particularly in multifamily. To my knowledge, there's really no practical solution because of the air and volume constraints in that small dwelling. So electric water heaters are huge to the transition, and it makes the cost effectiveness much more powerful in the transition. Once we get to scale, it turns out just about every appliance that can do even the smallest amount of shifting will be cost effective. Even refrigerators, you can show they'll be cost effective. But electric water heaters are going to be a very important part for at least the next 10 years.
Agreed.
Right. Okay, thanks. Let me move to Nancy Hirsch's question. She asked, how long does the peak reduction last compared to the morning and early evening peak? And maybe that's a question where, Conrad, you could start. And I wonder if you could, Conrad, you could mention your recent papers looking at the dispatch issues with water heating.
I'm not sure about the latter, but to the former, the peak reduction can be timed to exactly match the peak period. So this becomes a management issue when you have of the population, the large population of controlled water heaters, when you have a lot of them. So you can shape the reduction to match any load shape when you have volumes. You split the water heaters into groups, and then you stage them so you can get, you can clip as many hours as you want a certain level, depending on the other resources in your portfolio. But if you only had water heaters and that was your only demand response resource, then it would only be able probably to clip like 2 to 3 hours. But that's why we need to expand to the space heating and cooling loads. Ultimately, we need to get it in dryers and dishwashers, which have huge ability to shift when they can run, pool pumps. Not that we have a lot of those in the Northwest, but all of those loads have flexibility, and we're going to get to electric vehicles eventually. And as you combine all those things, you can clip a much greater duration of the peak load clip. But you can follow variation in real time And Portland State University under Bob Bass has done that. He'd be happy to tell you sometime. But it takes a lot of devices.
Right. And by the way, you mentioned Bob Bass, Robert Bass, and that was the one I was referring to. Conrad and Kevin Marnell, who was at Portland State, now at Pacific Core, and Robert wrote a paper that I think is in print, pre-publication right now in one of the IEEE journals, called Resource Study of Large-Scale Electric Water Heater Aggregation. Lots of really interesting stuff in there, kind of a simulation of optimal dispatch of water heaters in a grid that gets to this exact question. I want to move to the next question here, where Jeremy Smithson asked, many infill townhome projects in Seattle have used a single device for space heating and domestic water heating, typically gas-fired. How much resistance will you get from builders, and is there a plan to deal with this trend? So I'll open that up to anybody. Maybe Geoff Harris might have an answer for that one.
Well, I think, so the multifamily or mixed use building that has a central hot water system is a different animal than what we've been describing here. The 200,000 water heaters a year that are sold is a reference to what we would call an integrated drop-in replacement standalone water heater, like in mostly single family residential, although a chunk of them do go into multifamily every year. The central hot water system is a different animal, as I said. It's not that there's not opportunities there, but the central hot water system ability to shift loads back and forth is a function of the design for thermal storage tanks. It's true that many of those systems today are gas-fired, but increasingly builders are looking to electrify things as a choice for their projects. And so there's really good heat pump technology now. Ecotope up in Seattle has done a number of projects with Bonneville funding to test heat pump-driven central hot water systems for multifamily with really good results. But again, the ability of those systems to shift load is now a function of how much actual storage you put into the system. So it's much more of a custom one-off question rather than sort of a large-scale individual unit question.
All right, thanks for that. I think we're getting close to the end of the hour here, so I apologize to those whose questions I didn't get to, and for anybody else who wanted to bring one up. We'll definitely, if you can send us a question, fred@nwenergy.org if your question is not in the chat box, or for those who are in the chat box, we will, as I said, we will compile a response to all the questions. So let me just end by thanking our four panelists actually from three organizations here, Conrad Eustis, Geoff Harris, Geoff Wickes from NEA, and Tony Koch from Bonneville, for a really great presentation. You can see the depth of the thinking, the different layers of issues that they've contended with to produce a really successful pilot or test program, the Bonneville-sponsored CTA 2045 field test, and all that's going to come out of that, and the opportunities we have ahead of us, not just for grid-enabled water heaters, but for a whole range of other devices, and a really important kickstart for the demand response scale up that we really need in this region to achieve our climate, clean energy, and equity goals. So with that kind of summary, I want to thank everybody for being on the webinar. Thank our presenters again. Thank Kat and the coalition staff for their support. And we will be doing two things coming out of this. First, we will have some additional webinars on what we're calling the Harmonious Grid theme, which this is the first one of those. We will be announcing those fairly soon. And the other thing is I'm hoping to start kind of an informal group that I've been calling Friends of Flexible Demand for utilities, advocates, agencies to get together and think about the the issues necessary to really get us to scale and how technically and from a policy programmatic point of view we can do that. So I'm hoping that this webinar will be the start of a very important new phase for our work in the Northwest. Thanks everybody, and we'll talk to you soon.
Thanks, Fred.
Thank you, everyone.